All right, this video is going to talk about probability. We've already discussed, or hopefully we've already discussed, how to count different various events. Now we want to talk about what's the probability of an event happening. So things like rolling dice or picking cards, how do we refer to probability? All right. Now, to understand probability, the first thing we need to understand is sort of the definition of probability. The easy way to describe probability is just that an event A is going to happen. The probability that event A happens is basically taking the number of ways in which that event can happen and dividing it by the number of ways that anything could happen, or what we often call the sample space, the size of the sample space, right? The sample space is all possible outcomes. And again, event A up here would be all the outcomes that we want, right, of A actually happening. So let's go back to this first screen here. Again, suppose we're rolling a pair of dice, right? Well, what's the probability of rolling snake eyes, right, or rolling a 2? Well, in order to roll a 2 on a pair of dice, we have to get a 1 and a 1. So there's only one possible thing that can happen. We need that to be a 2. There's one way to make that happen. And again, if you consider a dice, well, each dice can be one of 6 things, or basically any one of 6 things could happen on the first dice, any one of 6 things could happen on the second dice, or basically there's a total of 36 different things that can happen. So rolling snake eyes is one of those 36 things, and basically that would be your probability, 1 out of 36. Now, again, you could always give that in decimal form as well. But again, for now, we're just going to leave that as a fraction. What's the probability of rolling a 3 on the first dice and a 6 on the second dice? Well, again, we've been very specific in that case. If we're going to roll a 3 on the first dice, well, that's one of the 6 things that can happen, right? And, which typically means multiply, we want a 6 on the second dice. Well, again, that's one of the 6 things that can happen. And really, if we multiply those together, just like the first question, the probability of rolling exactly a 3 on the first dice and a 6 on the second dice is 1 out of 36. Now, technically, that would be a sum of 9, but again, that's one of the ways in which to get a sum of 9. What's the probability of rolling a sum of 9? Well, now we need to consider what are all the ways to roll a 9, right? So we can, again, get a 6 and a 3, 3 on the first dice, 6 on the second dice. We could also have a 4 and a 5. A 5 and a 4, which technically, again, the dice are different. So that's rolling differently. On the blue dice, we got a 5 versus on the blue dice, we had a 4 in the previous scenario. But again, there look to be 4 possible ways out of the 36 possible things that can happen. Or basically there's a 1/9 chance, right? It's more likely because there's 4 ways to make that happen instead of just one way to make that happen. Again, how many ways can what you want to have happen be divided by all of the ways that anything could happen, right? The entire sample space is probability. So let's go down to the bottom. How about picking a card? Picking one card out of a standard poker deck. So 52 different cards, 4 different suits, right? We're hopefully familiar with the poker deck of cards. Find the probability of drawing the ace of spades. Well, again, that's one card possible out of the 52 cards available. And very simply, that's probability. Probability of drawing any ace, well, there's 4 different aces. We're okay. I mean, we just say there's 4 aces to pick from. We're going to pick one of them, right? So there's 4 different aces to choose from. Again, out of the 52 possible cards to choose from. Or essentially this time it's 1 out of 13, which makes sense. We're picking one of the aces essentially out of those suits, right? So again, there's 13 cards in a suit and we want the ace. But again, there's technically 4 out of 52. It all kind of relates. Anything except an ace. Well, in that case, what we're going to use is what's called the complement. Let's jump to our next screen here again. The complement of an event is essentially the probability that an event won't happen, right? The probability that an event won't happen. And since probability is basically taken out of 100%, or basically all probability decimals fall somewhere between 0 and 1, the sum of all possible probabilities has to add up to 1, right? It has to be 1. So in that case, well, anything except an ace, well, the probability of getting an ace is 1/13. Probability of not getting an ace is 100%, right? Everything that could happen, minus the stuff we don't want to have happen, or basically 12/13, right? Everything that could happen other than getting an ace, right? Any other card outside of an ace. Again, that's taking advantage of, again, that what we call the complement of an event. Pierre-Simon Laplace put it really well. Probabilities at bottom, just common sense reduced to calculation. Again, it makes sense if you really think about it. Again, it's appreciating with exactitude. It's giving sort of a quantity, right, for reasonable minds. Again, what the reasonable mind would experience by a sort of instinct, oftentimes without being able to account for it. We know that there are a lot of cards that are not aces, so there should be a pretty good probability, right? 12/13, pretty close to 1 probability that that's going to happen, right? We also know there's only 4 cards in the whole deck that are aces, or even 1 card that's the ace of spades. 1 out of 52, right? There shouldn't be much chance of getting 1 card when there's so many other cards to pick from. So again, that's what we kind of mean by that statement. Again, big things to remember about probability. What do you want to have happen? Divided by anything that could happen. All probabilities fall between 0 and 1. 0 meaning it absolutely isn't going to happen. 1 meaning it's absolutely going to. And again, most probabilities falling somewhere in between there, right? And again, the complement, the probability that something won't happen. Down here at the lower right, you'll notice there's a few ways to write that, depending on how your book kind of maybe words that. Oftentimes we just say the probability of not A, right? Probability of A is what we think could happen. Probability of not A is its complement. Probability of A prime, right? Putting that little apostrophe up there. That's usually how many books will kind of note that, or if you ever see that, that's denoting not A. Or occasionally you might see just a little tilde, this little kind of wavy line in front of A, saying sort of not A. Again, it's not a negative, it's a tilde. It's a kind of a wavy line. But again, that's another way to do it. Again, most books I think that I've seen, just so you know, are going to use that apostrophe. It's just going to be a great way to kind of denote that. And that's how I'll refer to it. So let's take a look, just a couple of other experiments real quickly. Sample space, again, is all the possible parts of an experiment. So let's say we were flipping a coin 3 times. Again, we could get heads or tails any one of those times. One great way to represent the sample space is using a tree diagram, right? In your first flip, you could have been heads or tails. So then in the second flip, assuming you were heads in the first one, could be heads heads or heads tails. If it was tails, again, we'd do tails heads or tails tails, right? Denoting, again, tails first, then we get tails again, or tails first, then we got heads again. And then finally, take all 4 of those, and let's attach, again, a heads or tails decision to each one of them. Basically telling you that the size of the sample space, right, the size of that sample space is essentially going to be 8 different possible things, right? We could write them all down. This would be the actual sample space, but it's really the size of the space that we care about. Because now if we say, well, what's the probability of getting 3 different tails, right? Probably getting tails 3 times, right? Of getting 3 tails. Well, there's one possibility that's 3 tails in a row out of the 8 possibilities. So again, our probability is essentially just 1/8. What do we want to have happen versus what could happen? Down here at the bottom, same idea. What if we had 2 marbles are going to be selected from a bag without replacement? Now that gets a little bit fancy. They could be red, they could be blue, they could be green. So again, on decision number 1, we could be red, blue, or green. But realize there's 2 different red marbles. So again, we got to kind of denote that, okay, there's 2 possibilities there. There's 1 blue marble, there's 3 green marbles, right? Technically more probable to get a green marble, right? There's more of them available. But then after we draw that red marble, well, now that there's a red marble missing, there's only 1 more red marble possible, right? So again, there's sort of 2 scenarios, 2 times 1. There would be 2 ways in which to sort of make that event happen, because we could have drawn either of the red marbles, then the other red marble, right? So again, that provides 2 ways. Again, same thing, 2 times 1, there'd be 2 ways to draw a red marble and then get the blue one. You could draw red marble number 1 or red marble number 2. And again, 2 times 3, there would be 6 ways, right, to do a red then a green. Again, if we're going to draw a red and a green, we just multiply the number of ways that can happen. So again, we would sort of have to consider all the possibilities, right, multiplying the number that could happen at the first part and then how it's going to happen in the second part. Because in the end, technically, we had 6 different marbles. And again, there are 2 plus 2 is plus 6. That's 10 ways to do a red marble, then another marble. There are another 5 ways, right? If we add these up to get a blue marble, then another marble. And again, there are 15 ways. So 10 plus 5 plus 15, there are 30 total ways, technically, that this could happen. What's the probability of getting 2 red? Well, again, that was that top route. That was this route up here, right? Probability of 2 red. There are 2 ways out of the 30, or essentially 1 out of 15 possible ways. Again, you got to think about the size of the sample space. What are all the things that could happen, right? Drawing that marble. Well, and the easy way to remember to get that size of the sample space, you're drawing any one of 6 marbles. But then with a marble missing, you're drawing any one of the 5 other marbles. There should be 30 total ways to make that happen. And then we just need to consider the ways we want it to happen, right? Red, then red. Well, there's 2 ways to do that. Out of the 30 ways, that's a 1/15. I hope that helps you with probability. Feel free to talk to your teacher if you have any questions. Otherwise, have a great day.